Today's foundation models are highly capable reasoning engines, but they share a complete blind spot when it comes to your company's standard operating procedures. If an AI doesn't know exactly how you document code or update your CRM, it will guess, and those guesses lead to errors in production. We fix this gap with an agent skill. At a technical level, a skill is simply a local directory on your machine. Inside, you'll find a primary Markdown instruction file, paired with a subfolder of supporting reference assets, like style guides, code snippets, or API schemas. To see how this fits into your tech stack, we have to map the ecosystem. The agent acts as the brain. The skill operates as the manager, holding the SOPs. Your command line interface acts as the hands, executing local commands. And the Model Context Protocol, or MCP, is the tool belt connecting external APIs. Notice that skills do not replace your external tools or APIs. Instead, the skill provides the specific business logic that dictates exactly how and when the agent should pick up a tool from the MCP or execute a command in the CLI. Skills act as the strict translation layer. They bridge the gap between raw intelligence and actionable, company-specific productivity. Building an efficient skill starts with knowing what you are trying to solve. Capability skills are temporary patches. They teach a model a specific trick, like tracing a certain log file, until the model's next update makes the skill obsolete. Preference skills encode your permanent company IP, like your specific deployment workflows and style guidelines. Regardless of the type, your agent reads the skills description file on every single prompt. Vague essays waste context. You must write the description as a strict, concise directive. That includes defining negative triggers. Explicitly stating when not to use a skill prevents the agent from falling into token-wasting hallucination loops, where it repeatedly loads irrelevant instructions. You also need to audit your instructions for no-ops. If you tell an AI to write clean code or make it easy to read, you are providing meaningless filler. The model already biases toward clean code. These phrases offer no structural value. The same logic applies to rigid step-by-step workflows. If a process never varies, you should write a bash script. For an AI skill, you need to define overarching goals and tight operational constraints. Give the model a target and a boundary, then let it figure out the path. By eradicating no-ops and rigid steps, you stop the agent from executing blindly like a traditional script, forcing it to actually leverage its underlying reasoning engine. As you build out constraints, your files will grow. If you force an agent to load a massive 1,500-line multi-cloud deployment rulebook just to fix a single typo in the front end, you will max out the context window and cripple performance. Look at this monolithic file. How would you restructure this so the agent only ingests the data it actually needs for the task at hand? We solve this using progressive disclosure. You break the massive document apart, creating one primary hub file that links out to several isolated reference files. The strict operational rule here is that your primary hub file must always remain under 500 lines of text. Inside that hub, you instruct the agent to selectively search and read the specific reference files only when a contextual trigger is met. If the user asks for AWS deployment, the agent reads the hub, sees the trigger, and pulls the AWS reference file, while ignoring Google Cloud and Azure entirely. This modular architecture protects the agent's context window. You ensure rapid response times for simple tasks while preserving access to deep, complex knowledge for the difficult ones. Engineering a great skill is only the first phase. Because the underlying foundation models receive constant updates, you have to continually evaluate and maintain your skill library. This graph illustrates an ablation test. You run a batch of test prompts on the agent with your custom skill enabled, and then run the exact same batch with the skill disabled, comparing task resolution rates. As foundation models get smarter, baseline performance improves. If the ablation test shows the model resolves tasks equally well without instructions, the capability skill is obsolete and must be retired immediately. Effective skill engineering relies on 4 pillars. Write directives with strict negative triggers. Utilize progressive disclosure to keep hub files under 500 lines. Define constraint-based goals instead of no-ops and rigid steps. And ruthlessly retire obsolete instructions using strict ablation evaluations. Mastering these architectural rules allows you to take a generic, out-of-the-box model and refine it into an autonomous, highly specific senior engineer tailored to your exact workflows.